Hi, fifth graders. So I would like for you to have your notebook and your pencil. We're going to start with notes on page 46. We're going to multiply fractions. This is going to be day 2. I'm going to show you another type of model. Okay. So on page 46, right, multiply fractions. This is going to be day 2. So find where page 46 would go and write 46 at the top. And we're going to multiply fractions and whole numbers. And this is going to be with models again. Okay. So yesterday was day 1 with models. This is going to be day 2. And I'm going to show you another type of model. It's just another way to look at this. Okay, so let's review what we started with yesterday. Yesterday, we said that we can think of multiplying a fraction times a whole number as repeated addition. So if we were doing 2/5 times 20, we could represent the number 2/5 20 times, and then we would have our answer. We would just have to count all these shaded pieces. And yes, if you count these, I drew out 20 of these groups of 2/5. The good news is we're not going to have to do this today. I'm going to show you a shortcut with your models. Okay. I want you to make a mental note of what the answer is, though. So we have 40 out of 5 here. And so that means when we simplify it, 5 will go into 40 8 times. So 2/5 times 20 is 8. So let's see how we can get this another way. Okay. So our problem, again, was 2/5 times 20. So another way to think about this is we can find, that fractional part of the number. So we can find 2/5 of 20. Okay, so we can find this fractional group of this number 20. And I'll show you how it works. Your models today, we're going to use dots. They're really quick and easy to make. I want you to think of them as counters, like little pieces when you used to count 1 and 2 and 3. So we're going to arrange this number 20 into 5 equal groups. So I'm going to start with one group of 5. 1, 2, 3, 4, 5. So I have 5. This denominator tells you arrange this number 20 into 5 equal groups. How many more groups of 5 do I need to make 20? I'm going to need 4 total, so that means I need 3 more groups of 5. So this is 5. There's another group of 5. Now I'm at 10. Here's another group of 5, and I'm at 15. And here's another group of 5, and I'm at 20. Okay? So if I want to figure out how much 2/5 of 20 is, I can go back here. Now that I've arranged these groups into 5 different parts, do you see how these 5 parts go this way? All I have to circle is 2/5 of them. So this right here is 1 part of that 5 right here. And this is 2 parts of that 5. And how much do we get? 1, 2, 3, 4, 5, 6, 7, 8. So that means 2/5 of 20 is equal to 8. Let's see. Is that what we got over here? Using a different model, got the same answer. I would like to review the algorithm with you. I want you to check all your models with your algorithm today. Okay, and we're pretty much going to do all the models together. And I'll let you use the algorithm to find your answers and everything else. Okay, I know this gets confusing with models. So we have 2/5 times, we're going to write 20 over 1. Okay, I'm going to remember, you can't multiply a fraction times a whole number. Okay, the algorithm for multiplying fractions is multiplying the numerators, then multiplying the denominators. And the only way that we can get a denominator here and not change that value of 20 is to give it a denominator of 1. So this 20 becomes 20 over 1. Once you've done that, you can multiply. So 2 times 20 is 40. And draw your bar. 5 times 1 is 5. And so we have an improper fraction. Well, we know how to fix an improper fraction. We're going to divide 5 into 40 to fix it. 5 can go into 40 8 times. 5 times 8 is 40. We have a remainder of 0, so our answer here is just 8. Okay, let's draw a line. Let's try that again. Okay, so let's try it with 2/3 times 18. So what we're going to do here is we're going to find how much we have if we have 2/3 of that 18. We're going to find that fractional group of those 18 wholes. So we're going to start by looking at a denominator and say, oh, they want us to arrange this number 18 into 3 groups. So you have to think, how many groups of 3 are you going to need? How many groups? We need 6. So we're going to start here. We're going to do 1, 2, 3. That's only 3, so I have to keep going until I get to 18. Another group. I'm at 6. I need another group. I'm at 9. I need another group. I'm at 12. I need another group. I'm at 15. And I got to keep going. Now I've reached 18. Okay, and I've arranged these 18 into equal groups with 3 in each group. Now I have to figure out 2/3 of them. Again, and kind of what I do is I just focus on that original group of 3 I made, and I want to figure out 2/3 of them, so I know that this is 1/3 and this is another third. So that's where I'm getting that. So this is 1/3, this is 2/3. And my answer is all of these dots that I've circled. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2/3 of 18 is equal to 12. Okay, so let's do it with the algorithm and see if we got it right. So going back over here to this number, I'm going to write 2/3. It's going to be times, I'm going to write 18 as a fraction. I'm going to write 18 as my numerator. My denominator will be 1. And then I'm going to multiply across the top. 2 times 18, or 18 times 2. So I can do it over here. I'm going to get 16, regroup my 1. 2 times 1 is 2, plus 1 more is 36. And 3 times 1 is 3. So I get 36 over 3. Now, that doesn't match my number 12. Well, it's because I'm not done. I have to simplify. You're going to have an improper fraction, and you must simplify. So I simplify by thinking, how many times can 3 go into 36? 3 can go into 3 one time. I bring down my 6. How many times can 3 go into 6? 2 times. And I have a remainder of 0. So that means my final answer is 12. Does that match what I got with our model? Yep, they match. Okay, so I want you to get a piece of notebook paper. We're actually going to start going through our practice today. Okay. And I'm going to help get you started, and I'm going to work through some of these models with you. Okay, so starting with number 1. So this one is 3/4 times 12. Remember, what we have to find using this model over here, if we can find 3/4 of those 12 wholes, we'll have our answer without having to draw 3/4 12 times. It's a neat little shortcut. So I look at my denominator and it says you need to separate this number 12 into 4 groups. So I'm going to start by drawing 4 dots to represent the 4 I need in my group. So far I have 4, so I have to keep going because I have to reach the number 12. And I want 4 in each group. So I'm going to make another row of 4. And I'm going to have 8 now. I have 2 groups of 4, so I have 8. So I'm going to draw another group. So now I've reached 12. I've taken the number 12, my 12 wholes, and I've arranged it into 4 groups. This way I can separate out 3/4 of them. So I always look, okay, here's my 4 going this way. I think of this as being 1/4, 2/4, 3/4, and 4/4. Okay, and so I need 3/4 of them. So I'm going to circle one group of this 4 going down, one group of this one, and one group of that one. Okay, you can also just do one big circle of all of them around it. Okay, so I'm going to count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 3/4 of 12 is equivalent to 9. Now you have to check your models with algorithms because you could do them wrong, and you want to make sure you have the right answer and the algorithm is more reliable. It's the secret to doing every model correctly and identifying models is using your algorithm. So let's go through this algorithm again. So we have 3/4, and we get to keep 3/4 the same because it's already written as a fraction. But since 12 is not written as a fraction, we're going to make it have a denominator of 1 because it does not change the value. So 12 becomes 12 over 1. Now we can just multiply across the numerators first. 3 times 12 is 36. 4 times 1 is 4. So we get 36/4. But this is improper, so we can't leave it that way. So we think, how many times can 4 go into 36? We hope it's 9, right? Because that's our answer. And it is 9. 4 times 9 is 36. So we subtract it and we get 0. So our final answer over here also happens to be 9. So I want you to check yourself when you do your models. I want you to try them. If they don't match, definitely go with your algorithm. It means you probably did something wrong with your model. See if you can figure out what you did wrong, okay? But do your algorithm as a safe check, okay? As a safety net, okay? So number 1 on your practice today, when you go enter it, you just have to type in 9. It only needs numeric responses. All right, so moving on to number 2. Okay, so let's go through number 2 together. All right, so this one is, number 2 says 1/3 times 9. So I'm going to do 1/3 times 9. So when I'm making my model here, I'm going to think, because I don't want to have to draw 1/3 9 times. Instead, I'm going to find the fractional part, 1/3 of 9. So I'm going to figure out that fractional part. Of is another way in math to represent times, just so you know. So 1/3 of 9. So the first thing I'm going to do is focus on my 9 and think, I've got to break 9 up and put 3 in each group. So I'm going to start by just doing my 3 dots. 1, 2, 3. There's one group of 3. The denominator says separate that 9, put 3 in each group. So I got to do another one. I'm at 6. Got to represent 9 in 3 groups. Now I'm at 9. Now I just got to circle 1/3 of them. So I come back and look, here's my original group of 3. And 1 out of the 3 is what I'm going to circle. So I'm going to circle this 1 all the way down out of that 3. And that's my answer. So 1/3 of 9 is equivalent to 3. Let's check it with the algorithm. 1/3 times, remember we got to take the 9, we've got to change it to 9 over 1. And now we can multiply across the numerators first. 1 times 9 is 9. And across the denominators next. 3 times 1 is 3. And then I have an improper fraction, which you will have all day today. And all I have to think is how many times can 3 into 9, 3 could go into 9, 3 times. And 3 times 3 is 9. And I'm not going to have a remainder. I think I'm pretty confident in saying that all of your answers today are not going to have, they're not going to have remainders. They're going to be whole numbers. I hope that's right, but I'm pretty sure. If it's not, I'm so sorry. Okay, so you've got number 1 and number 2 of your practice. I would like to skip ahead, okay, to these problems here, like problem 9. Okay, so on my paper, I'm just going to write problem 9, and you can just write it down. I know it's out of order, but just pay attention when you get there, okay? All right, so let's look at this. It says that Miguel uses counters to solve 5/8 times 16. So it looks like he's been doing the same thing we've been doing, okay? So this says that you need to break up the number 16 into 8. And do you see how he has one group of 8 here? 1, 2, 3, 4, 5, 6, 7, 8. I got him right there. And then another group of 8. 1, 2, 3, 4, 5, 6, 7, 8. So it is broken up. So now all we have to do is go back and circle 5/8 of these 8 here. So this is one group of 8 right there, another group that's 2 8s, 3 8s, 4 8s, 5 8s. Okay, you can circle them as one big group. This is our answer. Or you can go back and circle. There's 1 8, 2 8s, 3 8s, 4 8s, and that's 5. Okay, we can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means our answer here is 10. And look at it, it's right there. But let's check it with the algorithm. Okay, so if we have 5 8s times 16 over 1, where did I get this 1? That's a whole number, and it's automatic to me now. I know I've got to make that 16 over 1. Now I can multiply across the numerator, 16 times 5. That's going to give me 30. Regroup my 3. 5 times 1 is 5, plus 3 more is 8. So that's going to be 80, and 8 times 1 is 8. Now, I can't leave this. I have to think, how many times can 8 go into 80? And can y'all already see it? Yep. Our answer, isn't it? So 8 can go into 80 10 times, can it? That's right. So our answer for number 9 is going to be 10. It's going to be A on your paper. Okay. All right. So I'm going to give you help. I'm going to leave you with in between. I'm going to do these models with you. Okay. And then I'll leave you on your own. Okay. So this one says, which problem does the model represent? Ooh, well, the good news is we don't have to count them all because it has told us that there's 28. So that's a good news. But what we need to do is we need to focus on how many are in each group. So I'm going to cover up all these and I'm going to count how many are in each group. 1, 2, 3, 4, 5, 6, 7. Boom, our denominator is 7. Did y'all like how I said boom? I liked it too. I'm tired. It's the end of the day and I'm loopy. So far I know that my denominator has to be 7 because I can count that they put 7 in each of these groups. There's 7 here, 7 here, 7 here, 7 here until they got to 28. How many groups of this original 7 did they circle? 1, 2. So that means it's 2 7ths times 28. So for number 10, you write it on your paper. You need to make sure you have 2 7ths times 28. That's answer D. Now, let's take a second to think. What if we had no way to figure it out? Well, we know that the circle part on any model represents the answer. It does. So our answer has to be 1, 2, 3, 4, 5, 6, 7, 8. So what you could have done if you didn't know any other way is you could have solved each one of these doing the algorithm until you found the one that gave you the answer. 1, 2, 3, 4, 5, 6, 7, 8. But for time purposes, let's just do the algorithm here with the one we chose. 2 7ths times 28 over 1. It might mean that you have to do a little problem to the side. 2 times 8 is 16. Regroup the 1. 2 times 2 is 4. Plus 1 more is 5. And that gives us 56 over 7. I already know that we got the right answer for sure because we had 8 circled in our model. So that has to be the answer here. How many times can 7 go into 56? Absolutely. It goes in 8 times. So again, that one fits all the parts that we see perfectly. The answer for number 10 is D. Okay, so I'm going to send you off to finish your assignment. So you're going to, when you open your practice, you're going to be ready to start question number 3. I want you to try the models a few times, okay? Make sure you check them with the algorithm. Okay, if your models kind of fail and you can't quite figure it out, then just default and answer less questions with the algorithm, making sure that you change this whole number to give it a denominator of 1 and make sure that you simplify. Okay? All right. And don't forget, you have 2 attempts on your assignment. All right. Have a good night.